Hello everyone, in this video we'll be talking about the proton and nucleon number. Right, by the end of this lesson, right, you'll be able to define what's a proton number and what's a nucleon number. Right, and then you will be able to deduce the number of protons, neutrons, and electrons in an atom based on the proton number and the nucleon number. Right, you will also be able to interpret and use symbols to represent elements, proton and nucleon number, symbols that look something like this. Right, so let's begin. So the first number is the proton number, right? And the proton number is just basically, as what name says, it's the number of protons in an atom, right? One thing that you must remember is that the proton number is unique to the element. So it's like the IC number of the element. It cannot change, right? So anything, you look at the screen now, anything that has 11 as a proton number has to be sodium. 11 protons has to be sodium. If I give one more proton to sodium, right, from 11 become 12, it cannot be sodium anymore, right? So it's unique to the element, right? And since an element, atom, right, is electrically neutral, the proton number is actually the number of electrons. So if you look at the periodic table, which is the one on the left, right, the number on top over here, the smaller number is the proton number. Now, let's look at the symbol form. The symbol form, the number here below is the proton number. So please take note that the symbol form and what you see in the periodic table is actually slightly different, right? But the smaller number is always the proton number. Okay, so what about the other number? The other number is called the nucleon number. Now, the word nucleon is probably a new word for all of you, right? But nucleon just means particles that are found inside the nucleus, right? So the particles inside the nucleus are the protons and the neutrons, and therefore the nucleon number is actually the total number of protons and neutrons in an atom. So it's also known as the mass number, and it depends on the mass of the nucleus. So the nucleon number is the mass of the nucleus, and since the protons and the neutrons are found in the nucleus, therefore the nucleon number is the number of protons and neutrons inside the nucleus. Now, if you look at the symbol form over here, 23 and 11, we just discussed that 11 is the proton number, right? And 23 over here is what we call the nucleon number. So by knowing the nucleon number as well as the proton number, we are actually able to tell, right, the number of protons, number of electrons, and number of neutrons inside an atom. So let's try some questions now. Right, so let's look at atom A. Atom A has a proton number of 4, a nucleon number 9. So straight away, I know that proton number is 4, so there must be 4 number of protons, right? And because protons and electrons in an atom is always the same, so number of electrons is 4, right? The number of nucleons, number of protons and neutrons is 9. So since there's already 4 protons, the number of neutrons must be 9 minus 4, 5. Okay, right, let's look at B. B has a proton number of 12, so immediately 12 protons, immediately 12 electrons because it's an atom, right? The nucleons are 25, so 25 minus 12, that would be 23. Then let's look at the next one. I'm given 14 protons, 14 neutrons, and 14 electrons. So the proton number is the number of protons, right? So this is 14. And nucleon is the number of protons and neutrons added together. So it's 14 plus 14, that is 28. Right? Lastly, D, proton number is 6. Right? So number of protons is 6. And because it's electrically neutral, so electrons is also 6. And neutrons is 8. Protons is 6. So the nucleon is actually proton plus neutron together. So that's 14. Right? So if you look at the periodic table, if we see the proton numbers over here, we'll be able to tell which element it is. Right? We cannot look at the nucleon number because proton number is unique to the elements. Nucleon number is not unique. Right? If you look at the periodic table, there are some atoms, elements that has actually the same relative atomic mass as each other. So it's not unique. But no two elements have the same proton number. Let's look at this example. Symbol form. So the number on top 10 is the nucleon number, also known as the mass number. And number 4 is the proton number. So after I've labeled this, I know that the number of protons is 4. Because it's electrically neutral, the number of electrons is also 4. And since there are 10 nucleons and there are 4 protons, so the number of neutrons is 6. Let's do one last example. Now, my symbol form, I only have the nucleon number on top, and that's possible, okay? So the number of neutrons is 12, but I do not know what's the number of protons. But I know that the nucleon number is 23. So if I take 23 minus 12, that is 11, and this is actually the number of protons. So since the number of protons is 11 and it's electrically neutral, the number of electrons is 11. Alright, so I hope that you know how to use proton and nucleon numbers to find out the number of protons, neutrons, and electrons in an atom. Alright, okay, bye.